So this is group 5. We're doing our project on golf ball dimples. So why do golf balls have dimples? Golf balls have dimples in order to increase their flight performance. The dimples accomplish this by reducing the force of drag by air and increasing the upwards lift. Dimples create a turbulent layer of air surrounding the ball, altering the viscosity of the outer surface of the ball, which in turn reduces the drag force acting on the exterior surface of the ball. This allows the airstream to hold a tighter radius around the ball, therefore reducing the low pressure area behind the ball and further reducing the drag force.
Doesn't want to stick to the surface. It wants to stick to the fast-moving flow.
The detached flow causes a wake to form behind the ball, which creates a low pressure zone. This zone is what causes drag.
And that's almost like a vacuum. That's sucking the ball back and slowing it down in the face of the wind.
Adding dimples to the ball changes how the air flows over it. As the air travels over one of the dimples, a tiny pocket of turbulence or air disturbance is created on the surface.
It tries to go in and then has a region where it's actually detached, but then by the time you get to the next dimple in the ball, it reattaches itself. And in the process of that detachment, reattachment, that's what creates the turbulence.
Instead of impeding the flight of the ball, these tiny pockets of turbulence allow the closer layer of air to travel tighter around it.
Because these dimples have caused some low-level turbulence. It's mixing the high-speed air from out here and bringing it close to the ball so that that flow can remain attached to the ball.
A more attached airflow creates a smaller wake, and thus a...
Okay. So we used Bernoulli's principle to help describe the drag force behind the dimples. And as the speed of the flow increases, the pressure of the airflow on the ball decreased. This also relates to Reynolds number, which is the ratio of inertial to viscous forces. And the formula is presented there. So our hypothesis goes like, why do dimples on a golf ball help players? And we explain that by stating that a golf ball usually has anywhere from 300 to 450 dimples on it. Having the design allows for players to more accurately control the ball heights and paths and other related items. An analysis of golf ball dimples is pretty complex with a 5-variable function, but through dimensional analysis we can bring that number down to 2 variables and get the drag force equation, which helps allow us to calculate the amount of drag force behind a golf ball. So in conclusion, based on our findings, having a large number of dimples on a golf ball is based on the Euler's principle, which states that the separation of the boundary layer is likely to occur in regions where the pressure increases in the direction of the flow. It applies to why the smooth golf ball has more drag compared to a golf ball with 300 to 450 dimples. In conclusion, the less drag on the ball results in more control and a greater flight duration. Thank you.